Hello, my name is Christopher Puget, and this is the Shape Import Export Utility for Civil 3D session. A little bit about me. I'm a licensed civil engineer in the state of California. I'm a former AutoCAD Civil 3D certified professional. I'm an Autodesk Expert Elite alumni, meaning that I'm no longer in the program. I do programming, and I've written most of the Shape Import Export tool, or the starting of it, through my company, Civil Reminders, and I also have a blog, Civil 3D Reminders. All opinions and views expressed in this presentation are mine and don't represent any other party that I may have an association with, including my day job. So why do we have this Shape Import tool? If we look at the processing of survey data, we have to ask, is Civil 3D suitable? We have the survey database, which I find hard to use. Trying to resolve crossing breaklines can be a bit of a slog, breaking the data apart or the survey figures apart, and then making sure all the data is correct can be a little bit difficult. And once we make those changes, there's no real connection between Civil 3D and the survey software. So if I want to reflect that change within the survey data, I can't really do that easily. I can also use text files to bring in the data, in which case if I want to have lots of attributes on my data, I'd use user-defined properties, but I find that sometimes they aren't reliable and they lose their connection and lose their data, especially when you modify the data. And once again, we have a problem of no connection between Civil 3D and the survey software. So we have to ask, do surveying software companies do it better, right? Do Trimble, Leica, and the like do it better? In this presentation, I'll be focusing on Trimble products because that's the workflow that I am used to, and using Trimble Business Center. But as long as whatever survey processing software that you use can export out to shapefiles, this workflow within Civil 3D should work. And from the surveyors that I've talked to, they find Trimble Business Center easier to use than Civil 3D. It has better surveying processing tools, which makes sense since they're in the business of surveying software. And it maintains the connection better to the survey observations. I don't have to go back and figure out what has changed when I modified it within the survey database within Civil 3D. So that leads to the Caltrans Surveys Asset Collection workflow, where it's going to take the Trimble Business Center data, export it out to a shapefile, and then import it into Civil 3D. And so I'm basing this presentation on that, and that's the customer who's that process works for. So it starts with Trimble software, starting in the field, collecting data by the surveyor. So they're going to use Trimble Access or Trimble data collectors to go grab the data and then add all of the codes and categories to the data that they're collecting. It's going to be brought into Trimble Business Center and processed, and then in Trimble Business Center exported out to shapefiles. Shapefiles are used primarily because it doesn't support curves. Different software packages support curves differently. So in order to have a definitive answer, all the curves are tessellated, and so when you get the data, you know it's accurate to what the surveyor wanted, not modified based on that curve. So that's why shapefiles were picked in this case. And then the shapefile is then used to import into Civil 3D using the Shape Import tool, and that's on the Autodesk side. And that's what I'm going to be focusing on in this presentation. So some aspects of the CSAC is allowing alpha coding. So it starts with, instead of using point numbers, focusing more on alpha coding, allowing letters and numbers within it, and then using the name function for COGO points within Civil 3D. You can have a robust variable attribute coding for points and lines and feature lines. And we'll see how that's been applied via property sets and having groups of categories and then codes that allow us to break the data up into logical categories. And then we can tag on the data what type of surface is going to be, what type of data the survey represents. right? Does it represent a ground data that I need to add into my surface? Does it represent a bridge deck, either underside or ground underside, so I can figure out what the clearance underneath the bridge is, and then what type of features such as metal beam guardrail, signs, and other roadside attributes or objects that I might want to collect during the survey process. And then I can link my photos and my documents. So when the surveyor is out in the field and they take a photo, I want to have an ability to quickly open up that photo and see what the surveyor saw while he was out there. What does that sign look like? And the shape import tool allows us to have a workflow that links it really quickly. It also allows multiple coding at the same point. So I might collect the metal beam guardrail, which would be a feature, but I also want those shots to represent the ground. And so I'd be able to do both at the same time. And then I want Trimble Business Center and Civil 3D to look the same, have the same topology. And so Shape Import Tool allows us to stylize the data as it's brought into Civil 3D. So if I do the legwork, I can have it look the same in TBC as in Civil 3D. So Caltrans uses a feature code library, and it's split up into feature code categories, being the upper level. And it's broken up into what I think are logical groups or categories, such as roadbed, roadside structures, and vegetation, and the other categories. And then below that, for each one of them, we have feature codes. So for example, for roadside, I can have an asphalt edge, which would be the description. I have my AC feature code, and that's going to represent a line. So as the surveyor is collecting data, they can use these feature codes to communicate what is out in the field. And within each one of these feature codes, there's sub-properties that they can have to describe it further. And so the shape import process starts with queries, right? We want to know what data that we're bringing in and how can we leverage that data to get it to be displayed correctly and applied the information correctly. We want styles, so we're going to use those queries to figure out what styles should be applied as it's brought into Civil 3D so it looks the same as Trimble Business Center. And we want to apply that survey data as property sets so we can see the information that was collected in the field. So queries. So within the query pattern has been picked to look similar to Map 3D in that language that it uses, as well as the COGO point. So the dialog boxes should look somewhat familiar. So the queries start with a description of a point setting name. It's going to first query what does that file name look like. And in this case, when it's exported out of Trimble Business Center, it's going to be control_point.shp. And if the file has that description, this setting is going to be looked at. And then over here, there's a query column. And if we click on that cell, it's going to open up the Shape Query Builder. And here we can look and grab a property. And in this case, if the accuracy equals supplemental control and the type equals horizontal, it's going to apply this setting and apply all of the columns that are within it. And so using this method, we can quickly create our shape files, query the data, and then it's going to be stylized correctly. You don't have to use the UI if you just want to type. You can always type down in the box, and it's going to parse the query. And the next time you open up the dialog box, it's going to fill this in, the UI in, based on what you've typed down here. So just bringing in the queries isn't enough, right? We want to query the data as we bring it into the drawing, or once it's in the drawing. So in this example here, I can add a property set that indicates that in the surface, that property is set to no. It'll be listed or collected, and in this case, it's feature lines. And then down below, I could see all of my feature lines that are ground shots that have the in surface set to no. And that would be an indication that I need to add them to a surface. And then I could quickly right click on these feature lines, select them, and then add them to the surface as a break line. Or I could automate this process by writing some .NET code and some Lisp and have a button that'll automatically go in, find this query, and then add them to the selected surface. So styles, as we bring in the data, we want it to style and look the same as in TBC. So you're going to set up all your file names. Here we have the priority. So if there's multiple file names and they overlap, I want to give it a priority. So it's going to go and grab whichever style setting has the higher priority. And then in this case, for the feature lines, here I have the name format. So it's going to give it a name. I can give it a style. So if it meets this query, so in this case, if it's ground or the DTM type is none and it has an aspect of top, it's going to go and grab this style of bridge rail top. So as I bring in the data, it's going to automatically be styled the correct way. Now you may see a lot of these magenta styles that are within this drawing, right? So I can set up my settings. So if something's not on the correct style or it's been missed, I give it a style that's, I can visually see that there's something wrong. So in this case, any of the magenta lines aren't stylized correctly. And so I can use this tool to figure out, do I need to add in some additional queries rather quickly? In this case, I'm using a newer data set of shape files compared to this, just to illustrate that you can quickly find stuff that isn't stylized. So as I bring in the data, I want property sets to be assigned to the objects. And that's going to be done through the settings. And if I go to the property set column and click on the cell, I'll get the shape property sets dialog box to show up, where I can choose what property sets to be assigned. So in some cases, it's going to go open up the shape file up here, and I can tell it what the default settings should be. In this case, the features are going to come from Trimble Business Center. But I could also use that surface status that I showed earlier, where I'm telling it to be within the surface. And that's going to be default to no, but then I can use this property set as a trigger to say, hey, I need to add it to the surface because it's a ground shot. And in my query, it'll list as a ground in order to provide or select that surface status. Once the data is brought into Civil 3D, I can then see that property set data. And so here I have the associated files. I have my attributes of the survey data that's being brought in. So here I can tell it's concrete is the material, right? So it's road bed, it's ground, so it's going to be used in my surface, and the feature type is curb. So instead of just having have the surveyor just be forced to pick a code, he can have one category in the feature codes and then add additional information to it. So maybe this curb was really a dike, and they could just type in the feature dike and control that information as it's brought in. Here's another example. Here's the roadbed line _ concrete property set. And so you can see it's a little bit more or less information because the settings are a little bit differently, but you can find additional information about it. So going in the AutoCAD properties can be a little bit cumbersome. So we need a way to just hover over the line work or the COGO points and show that information. So there's a tool called Show Property Sets that turns that on. And then as we hover over the line work within the drawing, it'll then show that information. This information or this Show Property Sets tool also works through an XREF. So you can XREF in your survey data and then hover over the line work and it'll show you that information through the XREF. once it's turned on. So it leverages the information that we have so the designer can quickly see what that information is. If the property set doesn't have any information, it doesn't display that within the list. So it makes this a little bit quicker and easier to see the information rather than having a lot of empty data. And then as we import it in, we need to figure out, like, where did this data come from? Just to answer that question, we have the shapefile information property set. And within it, it's going to tell me when I imported that data, what event name did I call it? In this case, it's just the default of import event, but you can name it whatever you want. When the shapefile was created, what the name of the shapefile is, and where it's located at. So now I have a paper trail on where that data came from and when it was created. And then I can also have a version feature code library property where I can track, like, how old this data is and what standard was used when it was created. So it answers the question of why something isn't what I expected it to be. So one of the benefits of using this workflow is that you can link photos and documents. And we can tell that a document is available is when we hover over the line work and we get these three little dots of varying sizes. That indicates there's some data, a photo or a document available. If I have the property sets on, it's going to give me a cue that I need to hit the control key and click on the line work to open up the links. If there's just one link as shown here, it'll automatically open up the image or the document in the default Windows program. And so it makes it quick and easy to do it. But I can have multiple photos or documents attached to an object. In those cases, it'll open up a property set file links for various reasons. One reason would be, in this example, for missing links. It is looking for this au.png file, but it's not there. And I can tell because the found out is missing as well as the file name. Another reason why it would open up is that there's multiple links. And in this case, I can just double click on the document or photo that I want to view, and that'll open up the document or file within the default Windows program. So there's missing links. How do I fix that? One reason that I might have missing links is that I put the file location is in a different folder than the root path or relative to the current drawing. So in this case, I have a lost images folder that has some of these images and documents. And so I can change that, and then it'll look within that root path folder and find my file. So it's flexible enough to allow you to set that root path to find it. The root path will be saved, so the next time you open up this drawing, it'll use that same root path. So you don't have to set it each time you open up a drawing. And then we may have the need to export it out, right? Because if we want to go back to Trimble Business Center or go to ArcGIS and bring that data in, we'd want a way to export it out if we've modified any of the data. And to do that, you do it based on feature lines or Kogo points. Here, if you have a vertical curve or horizontal curve, we may want to use supplementing factors and enter in the mid-ordinate distance to convert those curves into tessellations because a shapefile doesn't support curves. So it's giving you the control, letting you determine what that tessellation should be. And you can also select the attribute data you want to include. And then the Kogo points is similar, but there's no option to tessellate curves. So doing this process, there's some other features that Civil 3D is lacking that we may need or find helpful. And you can find those in the toolbox under the Shape Import Utilities, and there's various settings available. So I can, if I don't want to use the command, I can go ahead and use the settings to edit the feature line settings, the Kogo point settings, and you can import and export out property set data between drawings using that tool. You can also import in Civil 3D survey database information into the drawing, and that'll use the settings for the shape import tool. So within Civil 3D, there is a tool to check crossing break lines. But as we moved away from the survey database, there's no longer an option for feature lines. So we're getting rid of the survey figures, and this command will, or this report will no longer work. And if we want to double check our work in Trimble Business Center to make sure that Civil 3D is processing the data the same, we'd have to create a surface and then add the data feature lines to it that we want to test, and then run the command. So in order to get a cleaner workflow, the crossing break lines command has been, or report has been added to allow for feature lines as a separate command. What this command will do is it'll grab all the feature lines within the drawing, or the feature lines that are selected. It'll then create a surface for you and then dump it within the crossing break lines tool that's out of the box. And then you can use the tool to go and find your crossing break lines and where they belong or where they're at. So within Civil 3D, you can trim feature lines, but unfortunately, you just have one at a time. So you have to select your cutting edge and then select the feature lines you want to trim at one at a time, right? As I'm bringing in all this data, I may be an engineer and I just want to focus on one small area. If I'm a bridge engineer, I might just care about the feature lines within this area, and I may want to trim out feature lines on either side of where I'm working. So I can use the trim feature lines command, and that works more like the AutoCAD command, where I can select my trim boundary and then do a fence or crossing and then trim out those feature lines. So it leverages or provides a more user-friendly. Autodesk created the trim command like 17 years ago, and no one's gone back in and made it better. And so here's an option for you to trim the feature lines in a more faster method. We can also copy objects or Civil 3D objects from an XREF or a block. The AutoCAD one just doesn't support Civil 3D objects, and so there's a command that'll allow you to copy Civil 3D objects through an XREF. It'll also include the property set data, and this tool was developed to allow you to copy the line work from an XREF into the drawing, and then you can modify that object and then use it as a corridor target. There's point tables ability. And this point table differs than the one within Civil 3D in that it allows you to select up to 3 alignments and then report information on that alignment relative to the selected point that's being reported on. So here I can quickly get station offset information and include it into a table. Note that Civil 3D is really slow sometimes. And so in order to keep the performance up, because a user might have thousands of points or hundreds of points in this table, the table doesn't update automatically. And so to update the table, you just have to click the Update Point Alignment table, and it'll update that table. It's just done solely to keep the drawing performance up, rather than slowing down and trying to update this table over and over again. And then what is the future hold, right? Shapefiles aren't very useful long term, right? They don't provide us the transferability between platforms that we may need. And so the future might mean a common data environment that it goes into a database, and then that database can be pulled from ArcGIS, Trimble Business Center, Civil 3D, or whatever other product you might need the data in. And so having that connection to that Civil 3D or Trimble Business Center or ArcGIS, make sure that you have a common data. So once the surveyor is done updating it within Trimble Business Center, that data can then be pushed to the common data environment, and then ArcGIS is going to go grab it when you're in the viewer. And then Civil 3D will be a more manual process because it's a old program that isn't very forward thinking, and that you'd have to re-import the data within Civil 3D, since there's no mechanism right now to go and update that. And so if you want to get some sample data to try this out on, you can go find it on the Caltrans website. There's some consultant files that contain sample information about the feature code library, what some of the codes are. There's an XML file. And then you can find the settings in the Caltrans Civil 3D resource files, and you can go and download that from that location. And so this concludes the Shape Import Export tool. Does anyone have any questions? If you were live in Autodesk University, you could ask them. But if you want to provide some down in the comments down below, I might answer them.